Algebra 1, Lesson 117, Direct and Inverse Variation Squared. So, what we're looking at here is, well, in the book they show you the scale factor method. I'll go ahead and show you the proportional method as well. The only difference we're going to see in wording here, I'll go ahead and go to a practice problem, is the word square. All right. So, here they say the distance required for an automobile to stop is directly proportional to the square of its velocity. So what it's saying here is the proportion is not just, let me write this here. So normally if we were doing a proportion of distance and velocity, we would have distance 1 over distance 2 would equal velocity 1 over velocity 2, right? Now, when they say it's directly proportional to the square of its velocity, what that means is it takes this proportion, and instead of it being normal like this, it takes the velocity in the equation and it gets put squared to the second power. So this becomes the actual proportion. And again, this is direct variation right here. So this is direct squared. And then we could also do this equation with the scale factor method. So we would say that distance 1 is equal to the scale factor, or the constant, times the velocity squared again. So this is direct variation squared. So let's go ahead and solve this problem. Let's see here. So we've got our equation down, and they tell me that the car can stop in 200 meters at 20 kilometers per hour. So I'll go ahead and do the proportional method first. If the distance 1 is 200 meters, then that means velocity 1 is going to be 20 kilometers per hour, but that is going to be squared. Right? And then they tell us, or they ask us, what's the distance if the velocity is 28 kilometers per hour? So I go over here, distance 2 is unknown, and velocity 2 is 28 squared. So what I need to do here is simplify, cross multiply, and solve. So I got to deal with these radicals. 20 squared I know is 400 because 2 times 2 is 4. Add the two zeros. So this can be written as 200 over x is equal to 400. And then the denominator I don't know, so I'm going to go ahead and do an algorithm for that one. So let's take 28 times 28. Let's see here, that gives me 64. 8 times 2 is 16, plus 6 gives me 22. Put a 0 for a placeholder. 2 times 8 is 16. 2 times 2 is 4, plus the 1 is 5. And I get 784. So that is my, what is that? Yeah, velocity 2. So velocity 2 squared is 784. Now to solve, I'm going to go ahead and cross multiply. Oops, not my pen. Okay, so I cross multiply, and I get 400x is equal to 200 times 784. To solve, I will divide each side by 400. And I know that 200 divided by 400 is just 1 over 2, so that becomes 1, that becomes 2. And the only thing I have to do now to solve for x is to divide 784 by 2, which, let's see here. 2 goes into 7 3 times. 2 goes into 18 9 times, and then 2 goes into 4 2 times. So 392. X equals 392. And we're doing this for distance, which was meters. So 392 meters. And that is our final answer. Now I'll go ahead and do this using a constant, or the scale factor method. So again, just a review on this method, what we do is it's like a two-step equation. We plug in distance 1, velocity 1, we solve for the constant or the scale factor, and then we plug that into the second equation using distance 2, velocity 2, and then that will give us our final answer. So let's go ahead and solve for the constant. Distance 1 is 200, so I've got 200 is going to equal the constant times, whoops, what's velocity 1? 20 kilometers an hour. I almost put V1. 20, and then that is squared. Okay, And then we remember that 20 squared is equal to 400. So this becomes 200 is equal to 400 times k. To solve, we divide each side by 400. So then I know that k is equal to 1/2. All right. So now that I've got my constant, I'll go ahead and plug that into the same equation using velocity 2, and then an unknown distance 1. So velocity 2, we said, was 28 kilometers per hour. So distance 2 is going to equal the scale factor of 1/2 times 28 squared. All right. And then we already found out that 28 squared is equal to 784. So zoom in here. So distance 2 is going to equal to 1/2 times 784. And then we already did that division, so we know that 2 can go in 392 times, which means that distance 2 is equal to 392 meters. All right, so that is direct variation squared. Now we're going to go over inverse variation squared. So really quick, it's pretty much the same concept. So this is the equation for direct variation squared. We see d1, v1, d2, v2, or d1 is 2 constant times v1. Now let's go ahead and do the equation inversely. So the equation for inverse, if I'm still using distance and velocity, it would change to distance 1 is to distance 2 is to velocity 2 squared over velocity 1 squared. So that inverts. And then the scale factor would be distance is equal to the constant divided by velocity squared. So that would be the new equation if it were inversely squared. Now let's go ahead and find an example where we use inverse squared. Okay, here we go. It says the weight of a body on or above the surface of the earth varies inversely with the square of the distance from the body to the center of the earth. So we've got weight inversely to square of distance. So this equation, instead of it being distance, is going to be weight 1, weight 2, and then inverse variation to the distance. So this would be distance 2 squared, and this would be distance 1 squared. And then the scale factor version would be weight is equal to the constant divided by the distance squared. So let's go ahead and solve this equation. Now, they say if a body weighs 10,000 pounds at a distance of 500 miles from the center of the earth, how much would it weigh at 50,000 miles? So our first weight is 10,000, first distance is 5,000. So let's plug that into our proportion. Weight 1, 10,000. And then distance 1 is 5,000 squared. All right, and then they want to know the weight if it was 50,000 miles from the center of the earth. So we got 5,000 squared. Now these are some large numbers to square, but there are some nice tricks that we can do to solve this. For example, these are both numbers ending in 0. So what I could do here for the numerator is I could just cover up the zeros, and then 5 squared is 25. Right? So I would have 2, 5, and then I count the number of zeros, 1, 2, 3, 4, and if I double those, that's how many zeros I'll have in my final answer. So instead of 4 zeros, I put 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll insert my commas. Now for the denominator, 5,000 squared, same thing. I'll cover up the zeros. 5 times 5 is 25. I've got 3 zeros, so I double that and make it 6. Okay, so this is equal to 10,000 divided by x. I cross multiply, and I get this huge number with 1, 2, 3, 4, 5, 6, 7, 8 zeros times x is equal to, I can just add these zeros. Let's see here, 10,000 times that, 1, 2, 3, 4. 4 zeros plus 6 zeros, so 2, 5, whoops, I don't even know where the comma is going to be. plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. And there's the commas. All right. So that's some large multiplication. If you guys have trouble multiplying by multiples of 100, just let me know. You might be able to do this a little bit simpler if you use scientific notation, if that helps you. But anyways, here's our equation. Next, all we have to do is to divide. So I divide each side by, what is this, 2.5 billion, I think. Let's see, 100,000. Yeah, 2.5 billion. 2, 3. And all I have to do now is start canceling some zeros. So that goes away, that goes away. Remember, I'm just trading 1 0 for every 1 0. All right, and then I've got 2,500 divided by 25. This is a lot easier to do. From here, I can know that 25 goes into 25 one time, and then I bring these two zeros up, so the answer is 100. So that's going to be 100 pounds. Oops, I forgot how to spell. 100 pounds, and that would be the final answer. All right, this is the answer using the proportion method. If you need to see the scale factor method, go ahead and see me in class. I'm not going to make this video any longer because it's already 11 minutes. But if you have any questions, let me know on Moodle. And if you have any trouble using this scale factor method, let me know. All right, I'll see you guys in class.